All right. So we've got a quick lesson today on area and volume.
Mm-hmm.
Um, do this one too. Um, okay. So on WeChat, I've sent the stuff that would be the homework. I'll throw it up on Skype once we finish. So we're gonna go through really quickly all of our volume stuff. So that's disk and shell method and volume by cross sections. In the free response, we'll look at one part that has an area bounded by two curves as well. So for volume by cross-sectional areas, the general idea is we can form any 3D shape by stacking a bunch of 2D shapes on top of each other. So if I had a 2D cross-section that was a circle, if I stacked a bunch of them on top of each other, then I would have a height number of circles, which would be a cylinder. So the volume of a cylinder is pi r squared times h, where h is how many circles we stacked on top of each other. If we wanted to change the size of the circle as we went, we could do that with integration. Because integration is just repeated addition or multiplication, we can use integration to continuously stack these 2D shapes on top of each other and then change the size of those shapes as we go. So a general form for the volume of a 3D shape would be here. So that's my integral from a to b of my area times our infinitely small change in x. Okay, so for my example, if I had this semicircle and I wanted to stack 2D cross sections on top of each other that were perpendicular to the x-axis and were squares, my y value right now would also be the height that's popping out of the page. So my area of each square would be y squared. If I wanted to integrate that from -5 to 5 in terms of x, then I would rewrite my y value in terms of x. So y is root 25 minus x squared. If I square that, that gives me 25 minus x squared. So we can integrate. That's 25x minus x cubed over 3, and then plug in 5, subtract what happens when you plug in -5, and you'll get 500 over 3. I'll review. Any questions on volume by cross sections?
No.
Okay, then we've got disk and shell method. So we use disk method whenever we're revolving around a horizontal line. It takes two arguments. So that's an outer radius and an inner radius. So for this one, we're revolving around the line x equals 0. My r1 is my distance to the outermost radius, so that would be this distance. And my r2 is my innermost radius, which would be this distance here, r2. So what I'm really doing is pi r1 squared, so I'm creating one disk, like this red disk here. That is the area of this entire circle for the outermost part, and then I'm subtracting the area of the innermost circle, which is the hole that you're seeing here. And then we keep stacking them on top of each other as our function keeps changing from a to b, and that ends up giving us a 3D shape. Although we can use disk method when we're revolving around a vertical line as well, we would need to change our formula to be in terms of y instead of in terms of x. So generally speaking, if you're given formulas in terms of x, then you want to use disk method whenever you're revolving around a horizontal line instead. So if in terms of x, use when revolving about a horizontal line. And then, of course, we can shift the axis anywhere you want to. So if I moved this axis down to maybe y equals -1, that would add one y value to both r2 and r1. Any questions on disk method?
No.
Shell method. So for shell method, the general idea is this. So if I have a shape like this that I wanted to revolve around a vertical line instead. So I'm going to revolve around the line x equals 0. That infinitely small shell would have a radius, a height, and then an infinitely small width, which is my dx, as I spin around this line. If I was going to take this cylinder, so kind of like a toilet paper roll, and then cut it and unfurl it, I would end up with a box-like shape that looks like this. This small side would be my dx. This long side over here, which is this distance around the shape, would be our circumference, or 2 pi r, and then my height would be my height. So multiplying that all together to get my volume would be 2 pi r hw, where w is my infinitely small dx. Again, it is possible to use shell method if you're revolving around a horizontal line, but you would have to be in terms of y instead of in terms of x. So as long as we're in terms of x, if we're in terms of x, use shell method when revolving about vertical lines.
Mm-hmm.
All right. Again, this is all review from 2-3 months ago. Any questions on shell method?
No.
All right. So let's try one. So we've got a baker making a birthday cake. The base of the cake is this region R in the first quadrant under the graph of f of x from 0 to 30, where f of x is 20 sine pi over 30x. Both x and y are measured in centimeters. The derivative of f is also given as 2 pi thirds times cosine pi 30ths x. If this region R is cut out of a 30 by 20 centimeter rectangular sheet of cardboard, and the remaining cardboard is discarded, find the area of the discarded cardboard. What do I have to do?
So 30 centimeter. Region cut out a 30 centimeter, 20 centimeter rectangular sheet of card. Oh, so the area is 600 first, and
Okay.
then remaining this. Oh, it's like this. So we have to find the area from, from area R. So it's integration from 0 to 30, fx.
Okay, if I integrate from 0 to 30 fx, I will get r. However, we're looking for the area of the discarded cardboard, not the area of the cutout.
So 600 minus the integration.
Right. Okay, so this is really more of an English problem than a math problem, I think. But we're going to cut out region R, and we're going to keep region R, since that's part of our cake. But we're going to get rid of all of this extra part of cardboard. Okay, so this is my total area.
600. Yeah, total area minus R area.
Okay. So that's 600 minus, and you told me the integral from what to what?
0 to 30.
Of
fx. And then we use calculator to solve it.
okay, I need one more thing for this integral though.
dx.
Dx, okay. So if we work that out, so our function of x is 20 times the sine of pi over 30 times x. And we're going to integrate that. In terms of x from 0 to 30. and then subtract that from 600. Okay, so that gives us 218.028 centimeters squared.
Mm-hmm.
Oops. 218.028 centimeters squared. Okay, we can check. So 2 points for our integral, and 1 point for our answer. I'm going to say those 2 points are probably we subtracted, and you've got your 0 to 30 fx dx, and then our answer's good.
Yay.
All right. Part B. We've got our cake's base is this area R. Cross sections perpendicular to the x-axis are semicircles. So perpendicular to the x-axis,
Oh,
we
okay.
have semicircles popping out of the page.
Mm-hmm.
Okay.
So, so you have to find the volume for that first.
Okay.
So the formula for semicircle is pi r squared divided by r, and then r
Wait,
is
hold on. Pi r squared divided by what?
2,
Divided by 2. Okay.
and then r is fx.
R is my y value. Looks good.
So we just plug in and then, but I don't know.
Well, how would I get the volume though first?
Oh, integration from 0 to 38
Times
dx.
dx. Okay, ADX gives me volume. So our radius is f of x, which is 20 sine pi 30x.
Yes.
So that's already in terms of x, and I can square that, so that all looks good. Okay, so 20 sine pi x over 30. Okay, and then once you've got your volume, for every 0.05 grams of unsweetened, sorry, we're going to use 0.05 grams of unsweetened chocolate for every cubic centimeter of cake.
Also times 0.05 from the number that we got. Yes.
Okay, and what would my units be?
Gram.
Okay. Alright, so let's go ahead and solve that then. So I already have our function in here. So I'm just going to integrate this again. This will be our function squared times pi over 2 in terms of x from 0 to 30. So our volume is our volume is 9,424.7
times 0.05.
I feel like I didn't half that radius, did I? I need to go back. Okay, so I made a mistake. I made a mistake when I typed that in. This radius is not just f of x. What should this radius be?
It's not fx.
F of x would be the diameter.
Oh, fx divided by 2.
Right. I almost didn't catch that. Okay, let's try that again. Fx over 2. I didn't catch it the first time. 20 sine pi x over 30 divided by 2. Okay, cool. So let's go back. Second entry.
So we can divide by 4. No, we have to do square first, so it's more complicated.
Okay, 2356.2.
That's our volume.
Okay, and then multiply that by 0.05 to get my grams. So I've got 117.81 grams.
Yeah.
Okay, and we'll check. Okay, 2 points for the integral. Okay, this was f of x over 2. We did square it. Okay, that looks good. We did multiply by pi over has. Go from 0 to 30. Okay, I think we're set. Last one, part C. Find the perimeter of the base of the cake.
Base of the cake.
Mhm.
So we just find the perimeter for R, right?
Right.
So integration fx from 0 to 30.
That's going to give me an area. What's my formula for arc length?
That's 1 plus f prime x square root. Square root.
Okay, square root. Say it all together.
1 plus f prime x square
Okay.
dx
In terms of
from
x.
0 to 30, and then plus 30.
Right. Plus 30 because we've got that base.
Yes.
Okay, should give me the perimeter. So we just need to plug that in. Okay, so that gives us 30 plus the integral. I need to derive this first, don't I?
No, it's given here.
Okay, so I just need to plug that in. 2 pi over 3 times the cosine pi x over 30. Okay, so oops, I'm not actually ready to do that yet, am I?
Square root.
Square root 1 plus our derivative
Square. Close, comma, x from 0 to 30. Yeah.
Okay, and then we already added 30, so that should be good. 81.8. So I'm just gonna double check this parenthesis really quick. 1, 2, 3. 1, 2, 3. Okay, cool. So that's 81.8.
Centimeter.
81.8 centimeters. Perfect. Okay, we'll check. Perimeter, integral, okay, looks good, and 81.8. Okay, awesome.
Yeah.
All right, fast lesson day. We've got A couple more practice problems for the homework under that free response set that I sent on WeChat. I'm going to try to resend through Skype and hopefully it'll work this time.
Wait, I finished everything?
So we're doing 1 through 3 today. We just did the first one together.
Mm-hmm.
And then we'll do 4 through 6 the next class period. So you are going to finish all of them by the end of the week.
Oh, so I do 2, 3 for today's homework.
Right. 2, 3 for today's homework. And then we'll do 4 in class next time. And then you've got 5 and 6 for Thursday.
Okay.
Okay.